Wesley, is it expected that we have quorum?
That we'll have quorum?
Yeah.
I mean, we've already met quorum for the meeting. Each
No problem.
ballot also has to meet quorum. So
Yeah.
that just means, you have to have enough non-abstain votes. So I went ahead and put that on there because sometimes people ask and I always have to remember anyway.
But we have enough registrations.
Oh, yes.
That's my question.
Yeah, we would have said something about that a long time ago, and I would have been begging a lot more people to be voting or to register if we hadn't been close. Yeah, we needed, I don't know the exact number we needed to meet quorum this time, but we were well over it.
Okay. Oh, okay. That's the 23 of 30.
Right.
Okay, that's good.
Hello, everybody.
Good morning, Martin. Afternoon, evening, whatever.
Whatever. We need to define a ground zero, a universal zero time for MPI and refer.
Well, I mean, we cover all cases because we've got morning for the US, afternoon, evening for Europe, whatever we want to call what a sushi's going through.
Middle of the night.
Yeah.
Good anywhere on Earth to you, Wesley.
Yep. Thank you, Tim.
Let's give people, as usual, a few minutes to join. We've had more people the last couple of days, so probably a good thing.
Yeah, we've had almost everybody that registered show up. I think we had 4 people that haven't come, but they've had other people at their orgs covering it, so it's been fine. Very good attendance since we switched to virtual.
Means we're gonna have fun with voting.
Yeah, I mean, as long as it's consistent, it's not a problem.
It means that we're going to have even more fun if we try and go back to face-to-face.
Yeah, that's the real rub. We'll have to see how that goes.
He's so wanting to go back to travel will be full.
Well, there's that, but there will be people who can't, and there will be people who don't want to, and then I have to call out 40 of your orgs or whatever. We got 30 orgs. I stick with the virtual voting just because it's a lot faster.
It's actually also more convenient because you have more time to actually cast a vote. There's actually less influencing, which is also good.
Yeah, I don't know that I want to say that it's good or bad. That's a part of how the forum's been for a long time. So,
That's
you know,
true.
there are good reasons for wanting to say that or voting a particular way. There are also good reasons for not wanting to have that at the last second. So I don't know.
We'll see. Well,
I
it is
miss
what
the
it is.
drama.
I do miss the drama. I agree, Catherine.
Memes are good though. I feel like we've really stepped up our meme game.
that is true, but I think that would have happened anyway if we had just been using Slack longer.
Fair point.
That's true. Now you've got the central meme, you got the side memes, you got memes all over the place.
But I think we can get the drama back since this is a big vote. I mean, Wesley, you need a power wall and you need to do all the exit polls and all that kind of stuff. There's no drama.
Hold on, let me get my John. I don't have a whiteboard in here. I thought I did. I got nothing.
All right, probably a good time to get started. Would you please pull up that one slide that's rotating that has the agenda on it?
This one right here?
This one. So that's what left for today. We'll start with the repeated Nona reading for 96, the semantic terms. We had a slight discussion over the last 2 days on this topic. We had a suggestion for the working group, and Puri, Dan, and Rolf followed up on that one. I think Puri can't make it in the morning, so I think Dan is going to present that one. And we hope we can get that resolved relatively quickly in the morning, in the first hour. Voting block starts at 10. We will do votes this time, not just promise them like the last 2 days. And then we have 2 more topics, one by Wesley, one by Ryan, on new stuff that is actually going beyond MPI 4.0. So these will be just readings. That's why it's not a problem to have them after the voting blocks. And I have a few things I want to talk about for the next steps for September and the way to September, as well as future meetings. There's the agenda, and then Wesley, you probably want to put up the votes real quick too, so people know what to expect. Exactly. So we have the 3 no votes that will come up. The 263 that Wesley read yesterday, 120 that Rolf read yesterday. We have the 96 that we're going to do in a second. And we have 4 erratas. We scrapped errata 301. There's going to be some more discussion on that one. And then there will be 3 first votes on 259, 120, and 96. And the second vote, in case you missed it yesterday, got delayed or got pushed off to next time because there were some questions, and we thought it's good to address these questions before we have it up for a second vote. That's at least how I remember it. That's how Wesley apparently remembers the 2. Anybody have any comments on this, or did we miss anything? All right. If not, then Dan, you're up for 96.
And while Dan's pulling that up, during the pre-meeting discussion, there was some clarification. We did meet quorum for the meeting. The 23 out of 30 orgs that we need there is for individual ballot quorum, not for meeting quorum. So that's the usual thing we have, that we can't have too many abstains.
Yeah.
So.
Okay, so this Puri put together a couple of slides. I'm presenting on Puri's behalf, so I'll channel Puri as best I can. So Puri put together a couple of slides here just to summarize what is actually in this no votes. I appreciate Jeff's comment yesterday and that there's been a lot of changes. There's been a lot of discussion. There's been a lot of movement on this, and it seems like it's a huge change now because we've discussed so many things and for so long. But actually, when you examine what the differences are between the reading that we did and the latest thing now, there are very few changes. Actually, there are just these changes, and each one of these is an individual thing with a good reason behind it, and actually isn't a huge, at least conceptual change. So I think that's worth doing, is just sort of showing that yes, we've had huge discussions, lengthy discussions, in-depth discussions, but the ultimate result of all of that is that we want to change this ticket by a very small increment, and that therefore we are still confident that this is a no vote sized thing. And obviously, if somebody disagrees with that, then they're welcome to vote no against this. But this is the the actual size of the no vote change. So there's the addition of a paragraph on partition communication that's necessary. Either the partition communication ticket or this should do it, and so we're second, so we're going to do it. That's just effectively that's a merge conflict, and it was necessary to do that because of the race condition between the two tickets. So we're doing that now rather than doing it as a merge conflict or as an errata later. So that's hopefully that's okay as part of the no votes. There is a reorganization and reworking of the text for request free. We've discussed that, and I think in this meeting the consensus view seemed to be that was okay, and so that is part of it definitely. Then the third thing, the resolution this time round is that whilst the table is quite close, it is asymptotically approaching a perfect table. That we are still concerned about some of the what is that last 1%? Do we want to publish something that's 99% of the way there when we this is tricksy? Let's move that into a separate document. So that's what we've done. Is Appendix A2 still exists, but it has a one sentence thing saying there's a side document, go look at it. And at some point in the very near future, we will bring forward what used to be in that appendix as a side document that then can be the target of that link, of that reference. So that's the biggest text change, as in the biggest amount of text being changed, but it's simply removing it so that it's not contentious anymore. And then the fourth thing is we shorten the changelog entry. So that's partly to do with removing all the references to the table. The changelog entry reference the table, but actually when looking at it, we decided to really drastically shorten it, in line with Bill's comments of we shouldn't restate what the change is. We should just have a brief thing to say that something's changed rather than redoing the change in the changelog. So actually those aren't particularly difficult or difficult to understand or big changes. So hopefully that with that summary, it's easier to see that this is really still a no votes. It hasn't accreted lots of small changes and therefore become so big that it's not a no votes. So there's relevant documents. There is the issue is 96, the pull request is 116. They have comments and the like on. There is a PDF from the June-July meeting. There is the latest PDF is linked there, so you can find those things. They are attached. I think they're attached to the pull request and the issue. I haven't actually gone to check, but there are links here. So if you want to follow along in your own copy of the PDF, then they are available. They're here. What I'm going to do is click on that last link, which is the link to the Git changes. The first commit being the one that was the formal reading in the last meeting, the last one being the head of this branch. So unless people have questions at this stage or want to stop me from doing that, I shall. Yes, I think that's. Oops. There we are. Right, that's the one I want. So this is showing 31 commits. That looks like it's a huge amount of things that have happened, and indeed we've done a lot. But what we've done is a huge number of changes to that table and then removed it. And so a lot of those commits are effectively undone by the last one or one of the last ones, which just removes the table. So it looks like there might be a lot of work going on here, and there indeed was. Puri has done a huge amount of work here to make this table, into LaTeX from pictures. and then to correct various entries and adjust things over and over again, and then we just remove the whole thing. So, okay, fine. There's more commits here than actual changes. So the first thing here is all of the LaTeX code that made up the table, and this is still going back to that last meeting. It's still actually importing images of each of the pages. So that's, as I said, that's one of the things that Puri spent a lot of time doing was converting images into LaTeX and so on. Well, all of that code is gone, and it's replaced with this one sentence, which is a summary of the semantics of all operation-related MPI procedures can be found in, and then a citation, which is in the references. So the table is not normative anymore. It's just pointing to a side document. Okay. So the next thing that to look at really is what does that citation look like? So there is an entry in the refs, the BibTeX file, a corporate author of message passing interface forum, title summary of semantics of all operation related MPI procedures, published in the year 2020, available online at some URL, which is where all the documents for the MPI standard are put. So that is where the official standards document is, but also where all the side documents are. And so it will just be one of the side documents in there, and you'll just have to go looking for it with that title. So it doesn't exist at the moment. That link won't get you to such a document because we haven't created it yet. But by the time this actually gets accepted, that's the plan is to at least put a placeholder where that thing points to, but probably just the content of A2 or the previous content of A2. Okay. So then let's do the changelog next. So that was the changelog entry. This is the new changelog entry. This is much easier to read. The semantic terms were updated. That's much better. There's no point in explaining what changed and whatever. All the references are still there. So if you look at the bit before this, it points you to all of the pages and places that have changed. So that's not different. So it's still going to give you all the page references and so on, but we don't need to explain what the changes are. You just go and find them in those locations. Any concerns about that? Okay, good. So then some of the other changes are actually removing references or references to this appendix. So this bit, the summary of semantics, that's not in that appendix anymore, and so we just reverted that back to the way it was, which is finishes the sentence with constants and types rather than and this summary. That's just removing a reference that shouldn't have been there now that we've removed the content of that appendix. Then this is an editorial change. I'm not going to deal with that because it's just use the right macros around in and in out chapter committee level stuff. The change in the point-to-point chapter is the text around request free. So there is changing the following operation to the following MPI procedure for a request object can be freed using the following MPI procedure. That's just factual correction. And then we went through all of this wording before in this meeting, and so we went through it, agreed on stuff, and I think that I'm just going to skip that unless somebody actually wants me to go through this again. We have been through this; it hasn't changed since earlier in this meeting.
Is everybody good and comfortable with that, or somebody wants Dan to read that part of the text again? Okay, it's quiet. I guess, Dan, you have your answer.
Okay, carrying on. So then in the terms chapter, so we're going back in the document, but forward in the lexical file names. So there is a chunk, there's an extra paragraph here, which was read, Puri read that before. This is to do with partitioned communication for a partition send operation. an additional call to activate each partition of the send buffer, see some section or other, is required to finish the starting stage. For a partitioned receive operation, before the operation is complete, the user is allowed to access a partition of the output buffer after verifying it has arrived. See section something or other. Those section references, we know what the actual references should be, and they're in comments on this thing. That will be done as part of the merging of this, but currently that chapter doesn't exist on this branch, and so those references would be broken if we tried to type those LaTeX codes in. So it currently has a static reference like that, which I know is bad form, but that will change as we merge it, and possibly as a separate thing afterwards. But we might just do it, and then when it merges, it'll work out. But if we put these codes in at the moment, it would just LaTeX would complain bitterly because these don't exist in this branch. That explains why this is a static reference.
Yeah, Dan, just a I don't know what kind of question, like a software engineering question. Would it be good to mark these somehow so that we're able to find them, make sure that they're all dealt with before the document goes out? Just, I mean, I was thinking, some kind of a special comment, or maybe we're already using percent ref as a way of marking them.
So I think that the resolution here is to immediately do this as a commit. As soon as people vote for this, what we'll do is actually do a commit on this branch that replaces the static reference with this. That will break. You won't be able to build the PDF from this because it'll break. Well, you'll get question marks here, but we'll do that as a commit on this branch so that by the second vote, you'll be voting for it with this code in, which evaluates the question mark. Either that or somebody will merge the partition stuff into this, and so the reference actually works. But I suspect the right way to do this is to fix the lack of reference here before the second vote. When the second vote happens, we're not voting something in that's immediately bad form or broken.
I mean, having a broken reference isn't necessarily a bad thing either, just because it'll be easy for us to find those as errors when we build the document. Right. My concern was just that if this goes all the way in to the LaTeX, might be something that we could miss later on.
Yeah, I mean, okay, so we can do that that sort of change immediately. I mean, it's really easy to do. It's just So yeah, I can do that, or we can do that later today if you want. It's just we wanted to be able to build the document with, and this was easier than doing the merge of the different branch.
Oh yeah, no, I understand the problem. That wasn't meant as a criticism. Just making sure that we're doing some good bookkeeping so that we can deal with these things later if they need to be dealt with later.
Yeah,
okay, thanks.
I think Wesley's put a comment on the pull request or the issue anyway, saying should this be a static reference? So in order to resolve that conversation, we really ought to resolve it. So I think there is a trigger for us to do this. Okay, so the rest of this change in this file is actually a resolution of a merge conflict. These changes have been done in the main branch, and in order to avoid undoing them, we have to do them in this branch. This is simply that we should have merged probably the 4x branch into this in order to get this to happen, but it's actually been done manually in this thing as a merge conflict resolution thing. So these aren't part of this ticket. These are just redoing something that's been done elsewhere, been voted in elsewhere. So I'm going to skip that.
Dan, what was in the line that was removed just before? You skipped over quickly. I didn't have time.
Which thing?
The line that was this annex.
Oh yes, well spotted. So that is a reference to the annex, which the annex doesn't have that in it anymore. So
okay.
That's an incorrect reference. So we could reference, one level of indirection. there is an annex which has a link which has this in, but there's no good reason for that. So we just removed it rather than trying to fix it in some way.
Okay, thank you.
Yeah, good spot. So the only remaining thing is the user macros thing. We could actually revert this change. This is adding the thick-h line that is the command that it does the double thick line or whatever it is in the table. The table no longer exists, so this command is no longer needed. It's not harming anybody, and it's just got missed. So we can revert this if you want. I really don't mind. It's not harming anybody by leaving it in, but it's not necessary either. So why put it in? Happy to follow whatever people want. So I think by default, I would just leave it because it's not harming anybody. But if somebody wants to object to that course of action, then we'll remove it. It's no biggie.
The only person that'll object, if there is anyone, would be Bill, and I don't think he's here, so do whatever he says later.
Yeah, okay.
Since this is not visible, this is a editorial change internal to the document.
Yeah, and if Bill wants to do that, he can do that. Either make us do it as part of this, or later as a editorial change.
Yep.
But it's there for completeness, just to say that is what has changed since the formal reading. So does that raise any concerns? Is anybody concerned about the size of the change or the nature of the changes or anything? Would people vote for this? Would anybody vote against it in particular?
So in particular, those of you who raised concerns yesterday, with the changes made since then, alleviate those concerns.
For me, yes.
Okay.
Yes.
Okay, good. Anyone else?
Anybody still have concerns about, so not the ticket itself, but about the changes made to the ticket since the reading? Anybody concerns about the ticket itself that still need to be brought up? Assuming the changes are made. All right, I guess we'll just put it up for a vote and see.
Sorry, Martin, just one point I wanted to mention to Dan and the terms guys. When we were going through this with committee at the lab and discussing it with several different people, there was some concern that the definitions of operations and procedures and how they're defined in operation stages may not match with certain areas of the text. So we're still reviewing all of that, but there's like hundreds and hundreds of instances of the use of the word operation throughout the text. So for an example, do you guys have feedback on the MPI type commit is considered an operation, but that doesn't seem to match the new definition of operation?
Yeah, I think that is a fair criticism. I think that the 4.1 cleanup thing there's going to be a lot of that sort of thing, and we might address some of those during the ratification and release candidate type meetings this time round, to catch them for the 4.0 time frame. Some of the more egregious ones might be caught there during that. It's one of the things that we probably ought to look out for. Indeed, part of the changes I'm showing here is to change the word operation to procedure for request free. Exactly for that reason is because that isn't an operation. That's the freeing stage of an operation. It's a procedure that does something related to an operation, not an operation itself. And so, yeah, I guess there is likely to be some additional cleanup work there.
Do we need a voting procedure, pardon the pun, for changing the word or an operational approach to changing the word if it's not changing the meaning? In other words, is it a chapter committee thing that could be cleaned already at 4.0, or does it require each such thing require an erratum or a ticket with the 2 votes to make those word changes?
I would hope that we can do these things as chapter committee change things in the same way as we can add MPI before MPI, to make MPI processes instead of process. I would have thought it. I would hope that these things are that sort of nature of a thing, unless there is some conflict, some disagreement about whether this thing is an
Well, there could be a
operational
whole
procedure.
bunch that are not controversial that could be done immediately by chapter authors at that stage, if that's the agreement of the group. Seems reasonable. That's why I asked you that rhetorically. Okay.
So, I mean, if it's really obvious, sure, but I think some of these things can get very subtle, and we've seen this, right?
Sure, Martin, so you just tell us what we're allowed to do in the chapter. You set scope for this potentially if there's not for that as we go visit Brian. Already has circled hundreds of them. They're already known.
So I also wanted to add, I like Dan's suggestion of doing this during the review of the document, because at the end, that's a consistency question. And those reviews we actually go through as a forum, and we look through changes made in this review process of the final release candidate. And if those get too much and we get worried about it, then we can see if we want to make a bigger procedure. But at least that gives us an easy way that doesn't hold up things. But at least everybody gets a look at it. I think that makes the most sense at this point.
And it also means that if there is a question of any sort over one of these changes, it can immediately be raised with the group and discussed,
Yes.
rather than either done unilaterally or skipped, because there's no certainty. And if it means delaying if we need more than one release candidate meeting or whatever because of that sort of change, then so be it, I guess.
Agreed. So I personally fully agree with that. Is there anybody who objects to this approach? Okay, so let's put that on the list when we do the review of the entire standard, and we probably also do the MPI process at this time, because we probably see something very similar. Since we're not doing this in the room this time, but are most likely not going to do this in a room one time, the idea was set up a list of criteria that everybody's supposed to look for, and we can easily add this, what we just talked about, to a list of criteria. And Ryan, if you have already a list, that would be the perfect time to bring it in.
Okay, yeah, I mean, I only have a partial list, but
Yeah,
there's
sure.
some stuff that's a little bit more egregious. Like if you just look at test sum, it actually calls it a local operation. And local and non-local are defined in terms of procedures, stuff like that. I mean, we stopped halfway through because we agreed that we couldn't agree on what we should do moving forward with whether or not all this stuff is defined. But we can continue looking through it, and I'll make a list for everybody off of what we found, but we're not going to find everything. It's just 2 or 3 of us, right?
Sure. But the list would be helpful. We'll talk about this when we do the release candidate, and then we can still take a vote as a forum whether we want this in 4.0, if we think that needs more review, then we can make it as a big ticket for 4.1. I mean, that's a decision we can take at that point. I would really take it pragmatically and see how controversial these things are at this point.
Yeah, I think as one of the chapter committee chairs, I'd be happy to have the partial list for my chapter sooner rather than later, so I can implement them and have them ready for that meeting as pre-done changes, and then we can approve them during that. Just front load the effort.
Admittedly, though, I mean, reading through the spec brings up more stuff than just like searching through the spec. So I think it probably is a good candidate for, a high on the list. Everybody should be on high alert for this when we do the release candidate, because it's really hard to try to catch this stuff as you look through. We have a few specific examples, but I think that we really need to read the whole spec to catch everything / most of them.
Okay, so I think that's me done.
Okay, if there's no more discussion, I think that is indeed it then. With that, we have the list of votes for today. Before we go into the new readings, we had a quick run through the individual votes and the ballots and issues yesterday. Is there any more discussion on those, or is everybody good just to go to the voting on it? Anybody who wants to plead for or against the ticket, or wants to make a comment or question for a ticket? Okay, then
I have a procedural question. So ticket 96 will go for a no vote, and then we'll go for a first vote. Is that correct?
that is correct, yes.
Yeah, we do all that together. So what happened at the last meeting was I had a ticket with a no, and Jeff pointed out an issue that needed to be fixed and voted no, rightly so. And so I just withdrew the full vote on that after the no failed. And normally that's easy to do because we do the votes back to back and we do it in person and we can easily withdraw that. So my, if we have anything like that happen again, I will ask the author of that ticket if they want to withdraw the full vote. Just in the same way we would have that opportunity to do so with an in-person meeting. So when each of you are voting, you vote as if the no were to pass. You vote for the no vote, and then you vote for the full ticket as if the no vote were to pass. And if the no vote doesn't pass, then that would just probably be withdrawn.
Thank you.
Actually, let's ask that question to the authors of 96 and 120. Those are the two which are actually in the errata. Is there anyone who would like to see the full vote, even if the errata fails, if the no fails?
I would withdraw 263, but that's
Okay.
very minor.
96 has Zoom as well, right? That's what we talked about, correct?
So I think the effect with 96 would be we would go back to having the table, but in a very prior state. There have been a lot of small tweaks to that table, all of which are significant, all of which make it better, and were incorrect before. So I think if we were to revert the appendix back to a state where we had lots of small errors in a table, I think that would be a bad thing for the ticket. The problem with that is that it would then miss MPI4 unless we start fiddling with the timescale again. So I don't know. I don't want to speak for the whole of the group on that. I would rather get something flawed in, I suppose, in some ways, and then fix the errata. Would be we could raise an errata to remove the appendix, do just that bit or something. It depends why somebody's voting no.
So, yes, in this case, Wesley, is there a procedural way to do the no-nos in the first 10 minutes and then the other ones in the next 20 minutes?
I just have to run it as two different ballots, so I could do that. It would just mean we'd have to hold the voting open longer. I don't know if that's a problem.
So I think it can be done. It can be done after the fact, in that people can vote. People are likely to vote. Yes in the no votes and yes for the ticket or whatever. They're dependent for each person. If the no vote fails, but the main ballot would have succeeded, then we can ask people after we've got that result in, why did you vote no? And if it's a reason that means we should withdraw the main ticket, then we'll withdraw the main ticket. If it's a reason that we can fix with an errata, we might accept that the first vote has succeeded and fix it with an errata or a subsequent no vote or something. I think it depends on why somebody voted against the no vote.
So I think the problem, Dan, is for each person, the way they vote on the full ticket might change if the no were to fail.
That's kind of what I'm fearing too, yes.
Yeah. So
Yeah,
I can certainly see that argument.
I think we should just adjust based on what the results are. Let's just run the vote and see what happens. In the happy case, everybody votes yes for both things, and it's all fine. It all goes away. if either of them fails, then we need to adjust based on why people voted the way they did.
Yeah, I think that's probably the best we can do. And if we need to rerun that ballot, we may just have to rerun that ballot a little
The
later.
other option would be just to duplicate the ballots for 96, and I don't know what Rolf wants to do with 120, and just have 96 raw, 96 with no. And then pick the right one based on how the no goes.
Yeah, we could do that. Add a second category to it, and have people
Possible,
vote.
Wesley, or is going to destroy your setup?
I'm just trying to think through what that's going to do. We can certainly try. I may get you the results a little slower. I don't know. I think I can handle it.
Okay, why don't we do that? So for 263, it's a clear choice. That will only be voted on if the no passes. For 96, you'll get two options: 96 in the prior state with the table in an earlier state, and 96 without the table and it fixes for petitioned. And for 120, Rolf, would you withdraw the ticket if the no fails?
There was a hint from Bill Korb in his that if in this case I should ask myself whether it should be fixed through an errata process. Therefore, it depends on the same as Dan said. It depends on the reasons for the failing. Because if it's only the reason we had it once to delay the process, that would be not a good reason.
Okay, then we'll do a dual thing for 120 as well. Is everybody okay with the procedure? Assuming Wesley can pull it off in the next 20 minutes. All right, let's give that a try and see where we end up. So the voting block will open in 20 minutes. Assume Wesley going to send an email at that point to everybody who is registered.
Yep, that'll all happen semi-automatically. I'll tell everybody when I'm going to do it, and then it will happen.
And then so if you have multiple people from one organization attending, it's up to you to organize who actually does the vote.
Or not. Whoever votes first wins.
Well, so
whatever.
Each organization is responsible that the right thing gets covered. Let me say it this way.
That is true. You should do that. But if you don't, that's the tiebreaker, is
Right.
Whoever comes in first, my script will grab.
Okay. So this leaves us then with 2 readings to do. Wesley, since you have to run the vote, I would probably suggest that we do yours second. Is that correct?
Sure.
It's up to you.
Doesn't really matter. I'm kind of ready to go. My only fear is that Ryan's going to take the rest of the time.
Okay.
And mine is rather short. We'll see.
Wesley, why don't I go, and then when you are done with that stuff, just interrupt me and I'll stop and I'll start again after you're done.
You know what? Actually, it doesn't even matter. If we don't get to mine today, it's fine. It's 4-1. So yeah, you go ahead, Ryan, because everybody wants to hear your thing and nobody wants to hear my thing. I'm right there with Fortran.
Okay, our stuff's also 1, so okay.
Yeah, but your stuff's interesting. Mine is removing error codes. So go for it.
Okay, give me 1 sec to present. I got it all arranged here. I just gotta.
Yeah, I need to start summoning some people that wanted to come to your talk anyway.
Okay, so I'm going to provide a bit of context here, just so that I understand too, for everybody who's on the call. Probably a lot of you should have seen the virtual meeting that we had. I sent it out in the announcements for this vote too, if you went back and review the overview of what we did for the virtual meeting. So let me just preface this with I'm going to show you a shortened view of the slides that lead into the proposal that I have here. If you want a much longer discussion on this, please refer back to the virtual meeting. That being said, if you haven't seen the virtual meeting and you need me to clarify stuff so you understand what I'm talking about, stop me. I'm happy to answer questions and go into more depth if we need to dive into more depth to understand this ticket a bit better. MPI psync. So we have partition communication, and if you remember, partition communication is aimed at multi-threaded, multi-core devices as a whole. Now, partition communication, from when the concepts were originally developed, which were actually 4 or 5 years ago by this time, so we've been talking about this for a long time, was aimed mostly at multi-core devices and what we anticipated was going to be the most popular multi-core solutions in the future. Obviously, GPUs are highly multi-threaded devices, but they don't match the exact same capabilities that multi-core devices 5 years ago were doing. So they have a few more restrictions, which is a good thing. We're restricting the space rather than trying to expand the space beyond partition communication. So consequently, we think partition communication is a really good match for GPUs and is an interface that we already have in the standard. So we can provide these solutions now to help out our GPU systems in the future. So what we really want to do is we want to constrict the space for partition communication to avoid a set of operations the GPUs and other data-centric accelerators, and this could also include FPGAs, are not particularly good at. So things you want to avoid, if you can, if statements. We could take them if we have to, but we want to avoid them if we can. Really want to avoid pointer chasing. You want high latencies in GPUs. You don't want to do a whole bunch of pointer chasing. CPUs are much better at this, right? So what this really follows to is things like opaque objects and a lot of progress. So we really want to avoid software progress of MPI and the accelerator kernels themselves. Supporting a progress engine on a GPU we don't expect will be highly performant. And we want to avoid operations, communication operations that require you to program a NIC from the GPU itself. So GPUs, NICs themselves will have command queues. You actually have to formulate a command, assemble all the bits of it, and ship it over to the NIC to write the results out over there. We don't want to do that command packing and shipping on a GPU. GPUs are much better at passing simple information over PCIe bus. So what you really want to do in this case is create the entire command, pack it from the CPU, right? And then send either no information, literally like ringing a doorbell from your GPU if you support triggered operations, or a very small amount of information to finish that command from the GPU to the NIC. So what we're doing here is we're cutting out that CPU path that a lot of the time you have to go back through, but still giving you partition communication, which remember is two-sided completion semantics. So P-ready and P-arrived are what goes on your GPU. You don't really get the same completion semantics there, but you're doing your inits, starts, and waits back on your CPU where they're good at it. So what we really want to be able to happen, which you can't guarantee with partition communication as exists today, is that the buffers are absolutely set up on both sides, the remote and local buffer, at the point at which you launch a GPU kernel. So you can have very limited interaction with the network, things like just triggering network counters to trigger operations to happen. So I will skip over what all of the working group discussions that we had and go to the usage model now. So this is the basic idea. From the host CPU side, you're going to do an MPI psend init. You're going to do some sort of for loop in which you're starting the request. You're launching your GPU kernel, which is going to do something on the other side. It's going to do some compute. When it's done its compute, it's going to mark those partitions as ready. Okay. Then when the kernel completes, you're going to wait on completion on the CPU side. Once the kernel completes, you can actually clean up the request with MPI wait, and then you can go back into MPI start and run the kernel again. The problem is that from this kernel perspective, MPI P-ready when you call it on the kernel isn't guaranteed that the buffer is set up on the other side. May require progression. There's a whole bunch of other stuff, but this is the simplest sort of GPU communication model that we can come up with that's also seems to be what you probably want to do on a GPU. I'm ignoring the arrivals and all that other stuff at this point, just the P-ready. This is probably the most performant path you can get. So just as a reminder, remember GPUs are not great at some operations. So the buffer setup lets us do a whole bunch of things that we can do ahead of time. Yes, it requires a synchronization. So unlike our multi-threaded core model where you do have good progression capabilities and the rest of it, where we can optimize things by eagerly noting that they're ready to send even though a remote buffer is not available, for instance, and how we can pack and reorganize messages to make them fit the wire format the best in terms of MTUs and using the most efficient message sizes. We're willing to give that up in the psync world on a GPU for the sake of being able to have a very easy to implement MPI ready on the GPU side. Now, I won't go into a lot of details on exactly what this is, but basically this ends up being a handshake that first time you go through an init object. So you're going to do I'm ready to send to you, you're clear to send. You can probably think about that for each and every single iteration. There's some optimizations you can do there. If the receive side is ready with its buffers, it's sending a clear to send really soon after it hits start, because that means once you've done start, the buffer's ready again to be written into, right? You have to control your writes between different iterations from the initiator side. So I will give you this example, which was psync. So this is how this fits in. It's MPI psend init, a start, a psync, which is blocking and non-local. So it's talking to the other side and guaranteeing that we're working. In a way, you can almost think of this as a two-participant barrier with some guarantees on buffers, but you know that's squinting. That's not exactly what it is, right? Then you're doing your p-readies, which are completely non-blocking. Potentially you're doing p-arrives. Then you're doing wait. Then you're doing that exact same loop again. Start, psync, p-ready, wait. Start, psync, p-ready, wait. Okay. Now I have two different ways I can show you guys the ticket. I've got this written. We'll just go over to the Git repo. But remember that this proposed operation flow is this. You do a first setup. You're doing a start, sync, ready, complete, and then you're coming back to the start potentially because this is a persistent operation. So just remember that. This is all in the ticket itself if you'd like to look at the issue ticket. Here is the change to this proposal. And remember, this proposal is for 4.1 at this point, right? So this is the first change from version 4.0 to 4.1. So I had to add all this header stuff in here. This is the changelog, just that in the partition communication chapter, we added calls for MPI sync and sync all. So this is
should that be psync?
Oh, thanks. Yeah, that's a typo. I'll fix that.
What does psync all mean?
But we're getting to that.
Okay.
Should that be procedures instead of calls?
Yes.
Okay.
So MPI psync is really simple, right? It literally just takes a request. It's an in-out. So MPI psync synchronizes with the destination of a partition communication request, guaranteeing that the receiver side buffer is ready to receive data. MPI psync is non-local and blocking. The partition communication request must be initialized, must not be inactive, e.g. MPI start must have been called, and no calls to MPI p-ready must have been made after the call to MPI start. Okay, so it has to be called between MPI start and when you call the p-readies. You're not allowed to mess around with stuff in there, and you have to call start before you call psync. If the user wishes to synchronize before beginning to call MPI p-ready calls, this call must be called by both the send and receive side processes for a given partition communication operation. Synchronizing prior to calling MPI p-ready is not required. Questions?
So I do have a question. You introduce a new function, so I assume it is different from just doing a receive from the sender side. You could achieve the same synchronization by having a receive of 1 byte on the sender side and sending 1 byte from the receiver side.
So here's the tricky part out of that. You're not actually guaranteed that the buffer is set up. Partition communication allows you to lazily register buffers, and there's a good reason for that. There's some optimizations that you can do when you lazily register buffers instead of waiting for the other side necessarily, right? So there's some flexibility that's allowed. So practically, in most implementations, that is true. You probably could guarantee that, but it would be implementation dependent rather than spec dependent. We allowed that lazy buffer registration because it allows you to push send completion to the side, essentially. Hey, this buffer portion is ready, but that other buffer isn't fully set up yet, and I don't actually know that it's fully set up yet. But that's okay. I can still be aggregating and planning how I'm going to move my partitions around to the receiver, even if the receiver buffer isn't exactly ready. So technically that's allowed. Practically, would an implementation do that? Probably not. But there are some interesting optimizations that you might be able to do by allowing the lazy registration and pinning to happen. So this is trying to provide that guarantee. The buffer is 100% ready and available on the other side. You can write into it.
Okay, thank you. That answers the question.
Yep. Any other questions?
So, yeah, let me just, I'm clueless guy coming in with this here. The intent here is to have a super fast, low overhead sync before you move into a restricted environment like a GPU that's not good at these kinds of things, so that you can have super simple fast path stuff down in these restricted things. Like I can guarantee everything's all set up, no ifs needed, no branches needed, all the things that you mentioned on the prior slide. That and the win is assumedly because you're looping down in the environment, and so doing a simple synchronization, even though it's a round trip, the overall is still a net win in terms of performance. That's the argument here, right?
Yeah, and I think your first point was the major one too. It super simplifies what you have to do on the GPU. Right.
The accelerator.
Yeah, it super simplifies the MPI call on the accelerator. MPI P-Ready doesn't have to go branching and checking whether buffers exist or not or any of that. If you created your P-Sync with a communicator that had info on it that was like a sync assert, you could make this even easier, that you knew that the sync will always happen. In this case, it's probably a bit you're passing into the GPU when you launch the kernel saying, hey, we're already synced. And that avoids tons of extra complexity. And most importantly, never having to do progress for P-Ready on the accelerator.
So how does that function articulates with the terms and semantic changes we've seen before? This is not completing any operation, or is it completing something because it's completing the registration phase?
No, yeah, you're right. It doesn't fit with semantic terms very well because we're exposing sort of more details about transfers here.
I would say that that's not operation related in the same way as a test that returns flag false isn't. It's doing the same sort of thing. It's more of like a query function or a side channel thing. It's an out of band thing. I don't think it certainly doesn't relate to any of the stages. It doesn't guarantee any of them. Start and P-Readies do the starting stage. You're still within the starting stage on the send side. Start began that stage and P-Readies finished that stage. This is simply doing a synchronization whilst that stage is concurrently with that stage. I don't think it doesn't conflict. I don't think it really impacts it at all. Well, that's at least my view of this.
Yeah, I'm not sure because it does advance the progress of the starting phase, right? It does guarantee something about the state of the starting phase, but okay.
Not locally. Not locally, it doesn't. I think it only tells you about the remote state. In not a dissimilar way to if you did a barrier. Something else, you know, you could synchronize it if you wanted to with a different operation. I don't think this is necessarily doing it. It's certainly not progressing as in completing a stage. Which stage is, you know, the starting stage was active, was in progress before, and it will be afterwards. It hasn't.
So, I mean, another way to look at it is that we have stages that are involved in an MPI communication or data transfer that just aren't exposed through the MPI interfaces. Mm-hmm. So this is true for existing send and receive functions, right? I mean, a lot of MPI implementations have a rendezvous that they would perform between sender and receiver to negotiate on how the transfer is going to be done, right? If you want to use RDMA, you have to exchange some keys and stuff like that. So this is, these stages exist already. We don't expose them in the interface, right? Essentially, this is saying there are some internal stages that aren't exposed through the interface, and this function is here to help an implementation advance through those stages.
Yeah, I mean, you could see this as being you're doing a standard, a synchronous mode send, and so you need a rendezvous protocol. The rendezvous is a synchronization of sorts. It's not a collective synchronization, but it is a synchronous mode. Means that it's going to do a round trip to figure out whether the receive buffer is ready or not. And the psync is just guaranteeing that bit of has been done. We've never exposed that before. We've referenced it before.
Right, the stages I mentioned, those are implementation defined, right? And we don't want to get into specifying any of that kind of stuff. I mean, it's entirely possible that an implementation could choose for MPI psync to be a no-op, right? Just because for that particular implementation, there wasn't something in the internal protocols that the psync operation was able to help with. We don't expect that to be the case, I think, because, you know, minimally, there are some partitions information that you would want to exchange between sender and receiver.
Yeah, I'm not sure it can be a no-op because there's a guarantee that you've synchronized that the start call has been made at the other side. I don't think that can be a no-op unless you're effectively, unless you know by some other means. How are you going to know that it's a ready mode? That you've done, you know that the start has been done before at the receiver side, before the sender side. How are you going to know that? I think it's not a no-op.
Well, so that's a fair point. Minimally it has to be a synchronization, but it might not actually advance the communication between the. My point was that an implementation may not have protocol work that they would want to be done in psync, so it could end up just being synchronization.
Yeah, you're adding potentially a synchronization that wouldn't otherwise have been there in that situation.
I mean, I guess coming back to the point I was trying to make is that we have these protocol states that exist already within MPI. They're implementation defined. And so this is a function which says there are implementation defined protocol states. This function is here to help an implementation advance through those.
Mm-hmm. And we're adding this because it's needed for, you know, this adds a significant optimization for some hardware types, right? Entire classes. Otherwise, we'd never expose any of this stuff, right?
So I mean, I would add to Brian's sales pitch too that this helps with, you know, multi-threaded implementations that are on the CPU as well, right? If you're able to so rather than having multiple threads all competing to try and progress through the stages of the protocol so that the data transfers can happen, you know, what you're able to do here is basically get things to a point where all the threads need to do is initiate RDMA operations. And that can help to cut down overheads and increase throughput pretty significantly. Particularly if you look at long vector features that are being added to new CPUs, as soon as threads start using these long vector operations, the CPU goes through a mode switch, which reduces its single-threaded throughput. So I think certainly this is something that for us to be able to use this in the way we'd like to on GPUs, I think this is a requirement. But I think the applicability is much broader.
So I agree with all that has been said before. So the question I was asking was, is this completing anything in the sense of the new terminology? I think it is not, as Dan was arguing before. So I think that we need to review this, or somebody that knows what he's doing needs to review this about, is it the completing call or not? But I believe it is not, and therefore what is shown on the screen is correct. That's my understanding at this point.
Yeah, I think in terms of the terms used here, non-local is clearly true because it's synchronizing in some, it definitely will not return until something else happens somewhere else. I'm less sure about blocking, but we'd have to actually think about that more carefully. It's because of whether this is related to an operation or not. It might not be blocking, as in it will block execution, but that's not what we mean by blocking.
So it is. I think it is blocking because it's non-local.
That's not. Those are orthogonal concepts. You can't say that. One does not imply the other.
No, it does. That's exactly what the new terms do, right?
No. Well, anyway, I want to review that. I want to think about that more carefully when I'm not on a call and whatever. So I think there is a slight concern there, but it doesn't matter whether it's. We'll just use the right term. Everybody knows what this thing does.
I thought, Dan, that the reason I wrote blocking here is because the only thing you pass into this is available for your use after it exits. When you complete this procedure, only thing that comes out of it is a request, and you are free to reuse those resources.
Yeah, it's
no
still blocking
or test required whatsoever. So it is non-local, and as far as I could interpret according to the new semantics, it is blocking because there's no resources that it retains ownership of that need to be tested for later to be returned to me.
Yeah, it's MPI start blocking. We need to. This needs to be taken offline, and we need to think about it. And maybe you've got it right. I don't mind.
I'm just letting you know what my interpretation was,
I know.
so that you can understand
That's
it for
fine.
conversation. That's why I wrote that word there. Okay.
So I want to break in here. We just went past 10 o'clock, so I sent out the voting emails, and so we should possibly take a short break to give Ryan a chance to vote since he's presenting.
Yes, please, because I am the rep for my org.
All right, let's take a quick break. Ryan, just let us know when you're ready again.
Okay, thanks. I will be I'll be back as soon as I vote.
Can I have a quick clarification on the votes?
Yep.
So first votes, number 96. Can you remind me, please? I swear I was listening. What with no means and without no means with respect to the table?
Sure. So because whether people will vote yes or no, you get the option to vote twice. Well, you don't have an option. You have to vote twice. Would you vote for 96 with the no changes or without? So the 96 no changes included specifically the table being removed. So if you vote for 96 with the no changes, you are voting for 96 after the table has been removed. If you are voting for 96 without the no changes, you are voting for it with the table as it was in July. I hope that's correct, Dan.
Thank you.
So also to clarify on this, if one would like to see 96 with the no votes, because they're like important, but you don't want to you don't want the full ticket to go down. Is there a second chance for September to get this through, or if I would like to see the whole package, yes, and then would, I don't know, abstain or no for the without the no. Does that?
Yeah, you can definitely vote separately for the two options. That's the way they were presented that way. If the vote fails because people are uncomfortable with the no but still want to see this move forward, and we need to delay things by a meeting, that's something we'll discuss afterwards. We haven't discussed what this means in terms of timeline if that vote fails. We'll do that later.
So I completely agree with that. I don't think the vote should be dependent on the timeline. We need to make sure that everybody, if you vote yes, you're comfortable with the content. If that means we have to have a discussion about timeline, we can certainly do that afterwards.
Okay.
Hey, Wesley, I'm sorry. I just want to be 1,000% clear because I was unfortunately 25 minutes late to the meeting today. So 96 with the no means remove the table.
Correct. Yeah. So Dan presented some things before you got in this morning that showed exactly what the differences that were, basically summarizing the last 2 days into 2 slides, which I think made a lot more people comfortable. I don't know, that's a little editorial, but just showing that they were removing the table, that the definitions around request free were clarified, and 1 or 2 other things, and I can't remember all of them.
Dan, sorry, Wesley. Dan, could you please put those slides back again so that people?
I was just thinking. I was just thinking of doing that as well. I'll just share that PowerPoint again.
Actually, so you don't derail everything. Feel free to send them to me on Slack, and I can just look at them if we don't want to.
Sure, let's do that.
Everybody to look at that again.
Yeah. Is WebEx clever enough to do a side meeting that we could have a 5-minute chat if you wanted, or?
Probably not.
No.
Okay.
Not in this form. I think maybe if you use a different version.
I think you can on Slack, right? Isn't there like a little phone button?
You certainly can on Slack.
Yeah.
Cool. Okay.
I'll bet your slides will be enough. Thank you. Yeah.
Sure. I just need to figure out how to do that.
Drag and drop.
Yeah, I've just got to find the file because I closed it because I thought I was done.
Oh. Sorry. Well, first you point the mouse and then you click the mouse. Don't make the mistake of clicking before you point because that'll get it wrong.
Dan, could you put it in the general channel on Slack?
Can I what now?
Well, if you're going to put it in Slack, I would also like to see it since I had to miss that.
He's asking if you can put it in the general channel.
Yeah, I can do that as well. Where's the general channel?
Thank
there
you.
Thank you.
That'd be there then.
Wesley, I'd like to disagree with you. It was 3 slides, not 2. Just to be clear.
Infinitely sorry. Somehow I think you will recover from the extra slide.
Where infinitely rhymes with not at all.
So I think that's my mistake because that's what my email said to Wesley. I forgot that the title slide was there.
See, it's only partially my fault.
I guess you just weren't paying attention when he presented it. That's fine. I got it.
Well, not only was I paying attention when he presented it, I read it before the meeting. I was really ahead of the game.
And yet you still said 2 slides. Okay.
Yeah, well, that doesn't mean I'm good at it. It just means I was early.
Eager.
Yes, eager. That's correct. Eager and inaccurate. Oh no, here come the MPI jokes.
Eager and in earnest.
Excellent stalling, everyone. I'm done.
Well, this was much better than listening to the girl from Ipanema or something, so go ahead, Ryan.
Like a gas, MPI form expands to fill all available talking time.
Absolutely.
That wouldn't be the first time.
Is there anybody who needs a couple more minutes for their votes? I want to make sure that people are not distracted by votes while we move forward on the ticket.
We have 20 of 30 votes in, so there's still at least 10 people considering it or not doing it at all.
Okay, well, why don't I give them 1 or 2 more minutes? People contemplate their votes.
I have a couple of points on this thing before you. So when you do move on, don't just scroll.
Plus one from my side.
I hadn't read all the text on the screen yet. So I wasn't planning on scrolling. So.
Okay, good.
Wesley, I'm supposed to. So I can vote yes for 96 with the no, and I can vote yes for 96 without the no changes?
Yes, you can.
Yeah,
Please
just
do.
like if we had an in-person, you would do the no vote first, and so then you would know when you got to the second vote, the full vote, what you were voting on. This gives you both options because I can't have a conditional form.
That's why we're trying to get the 96 done yesterday. 2 days ago and yesterday we failed.
Right.
That's why they're on one ballot now.
Oh, okay.
It's representing four parallel universes.
Yeah, okay. Is it a pain to do 2 rounds of voting?
Just because each one takes half an hour. Yeah. And in particular, there are people who couldn't be here at this time today and are possibly attempting to vote on a phone from like a doctor's office or something. So it's not a pain for me. It's more of a pain for all of you.
Next time we'll just schedule voting blocks for 15 minutes every 15 minutes of the meeting, and we can do votes all the time.
It'll be great. That'll definitely solve the problem.
Hey Wesley, are you planning on just putting up the votes that correspond with the no vote result though?
Do you mean, so on the web page, so having now thought about this for all of 30 minutes since it was proposed, I only plan to post the results of the vote that matters. I am not opposed to sharing the full ballot if people want to see the other ones, I guess, for the alternate universes. But I don't think it's helpful to post all those other things. Plus, I can make my script solve the problem you guys threw at me half an hour ago. I can't solve that other one that fast. So it would be more difficult for me to post all the alternate
I was
versions.
just concerned about it being confusing if you posted.
Yeah, exactly. I don't want it to be super confusing. So I'm just going to post the results of the no. If the author of those tickets decides to withdraw their vote, then I'll just mark that on the voting page the same way we did. You can see an example from the last meeting in June, July, where I withdrew my ticket that got voted down on the no.
Yeah, I don't object to the extraneous extra voting because when we're in person and we have no-nos and somebody votes no, we still take the rest of the roll. So
right.
Which always feels a little deflating when we're in person because it's kind of like my vote doesn't matter. It truly doesn't matter.
Sure. Well, that's one of the reasons I do the voting in random order when we're in person, so that fewer people feel that way, or at least it's a different set of people every time. And also everybody doesn't get influenced most by Argonne or whoever's last alphabetically. I forget.
Yeah, no, that's fine. I just meant those no votes where somebody votes no and you're after them. We could just stop. You can write down whatever you want for me after.
Sure. So I think we may have everybody that is likely to vote. We're still missing 2, but I think those people may or may not be able to. So
okay,
go for it.
So let's just continue on discussion here.
Yeah, I'll break in again in about 15 minutes or so with the results.
Okay. Dan, I know you have comments on this text. I'm just going to read the advice to users so that we've read the whole function, and then we'll discuss, okay? So the remainder section of this is an advice to users. It says, advice to users, it may be beneficial to synchronize partition communication buffers prior to beginning communication operations, particularly when using accelerators like GPUs to call MPIP ready. End of advice to users. Okay, now I have read the function. You had feedback, Dan?
Yeah, I think the first one was why is the request in out? it's not going to change the request at all, because it's not going to move anything on. There's nothing visible. It's not going to. It can't complete it. It's not going to. There's no reason for it to be an out.
Well, technically, the internal implementation may modify the communication request, but it's an opaque object, right? So you don't know what's happening with it.
Yeah, the handle is read-only. The content of the handle is modified, maybe.
Yeah. I suspect that on certain implementations, you want to put a bit on the request itself saying this has been synced. So technically it's an out because the opaque object that you don't know anything about has been modified.
I'm trying to think of a similar thing where we're basically sending it in as here's the object, but I mean, is the communicator object when I create a communication, that's an in, right? Because I might change the communicator object to say there's another pending communication, but I'm not changing the communicator. So I think it's an in parameter for a send, for example, when I send, but I might well change the communicator object that the handle points to. I'm not sure that fits the convention that.
Dan, I think we're actually kind of wishy-washy about this elsewhere in the standard. I think there are places where things are in-out where they shouldn't be. There's this weird clause in chapter 2 about it that is amorphous, and we have never clarified it fully about what exactly does in, out, and in-out mean.
I think there's a difference between saying it's in or in out in the LIS binding and whether you actually make it const and stuff like that in the actual language bindings. Clearly, this shouldn't be a const, pointer to a const object, because you might want to fiddle with it. But the pointer to it should probably be const. It can't be set to request null on the way out, for example, or replaced with a different request. I think anyway that should probably be looked at and a decision made.
Yeah. So this current in-out direction follows the MPI start semantics because it's also an in-out.
But so that's got a
kind of related to MPI start. That's where that decision came from.
I think that's one of the places where it's noted that that's probably a bad thing to have done, but we can't change it now because backwards compatibility. There's that, and for one of the others, maybe. Anyway, I have a vague memory of. Anyway, concern. Mark it down.
If there's larger concern, this is a very minor change if we can come to a conclusion on it.
Yeah.
So I have a couple fundamental questions about the semantics of the psync. So because we had discussion before, can it be a no-op, right? So if I have a compliant MPI4 implementation that implements partition communication the way we have specified it now, that does all the buffer checking in time because we don't know anything about accelerators or FPGAs or other stuff. In this case, is a psync okay to implement as a no-op, or do you actually need to wait for something to happen? Because the reason why I'm asking is the condition ensures that the receive buffer is ready to receive data. It's nothing that I can really test as a user.
Implementation, for example, may choose to do all of this in start to make sure that receive buffers are always ready to receive data when the start happens, because you might be doing a handshake in start, right? You're not prohibited from doing that in your implementation, but you're also not forced to do that, right? So if your start synchronizes, you'd no-op psync. So the answer is yeah. In some implementations, you might be able to no-op this, but it depends on what your implementation has done up to that point.
So surely that's not right. I mean, just thinking through this, start is local. It's not allowed to do a synchronization. It's not allowed to wait for something to happen. So if the start on the receive side had been done early enough that it had sent a message to the sender, which the sender had processed and thought, okay, the receiver's ready, then you call psync. Psync, at least, it can't be a no-op. It can be, at minimum, it can be, have I already got a notification from the other side that this thing has happened that I have to wait for? Right? That's not a no-op. It's an if. It is actually the second part of the synchronization.
You could implement everything with unexpected messages with no synchronization whatsoever.
That's more what I mean, right? If you have a current MPL4 implementation that has petition implemented exactly like Aurelian just described it, with unexpected on the unexpected queue and all that kind of stuff, so everything works. Does psync have to do something? So basically, does psync create a happens before relationship between the receiving and the sending process or not?
I would define that, Martin, if you have a bucket that you receive unexpected stuff into, the receive side buffer is ready. There is a receive side buffer. Whether it ends up being the application buffer is independent of MPI, right? We've said receiver side buffer here, not guaranteeing the application visible buffer is ready to receive data. You've got a place to put that data.
So there's even more fuzzy then, right?
So there's also what happens when that bucket is full. If I send faster than I'm receiving, I fill up the receive side buffer, and then I try and do a psync. It's now not a no-op. It actually checks this, how much space there is in that bucket at the receive side, and says there is no receive buffer available now, because I can't send another unexpected message because I haven't got buffer space for that.
Sure, but let me go back to something you were saying earlier. You said that if a call is local, I cannot communicate with the other side. Did you say that?
No.
Okay, good, because that was not my understanding.
Yeah, you can't wait for an MPI call, a specific MPI call in a local call, local procedure. So if the start is local, so it cannot block waiting for the other side to call start or anything else, right? Psync is non-local precisely because it is allowed to wait for something else on the other side. Psync, right? So you can't do the synchronization in the start calls, which is why you need a psync. Otherwise, you just wrap this into the start. There'd be no problem here, right? If you had a blocking start or a non-local start, then the psync is already wrapped up in that. Right? The argument for not doing this with the send modes and saying have a synchronous mode partitioned thing and a ready mode partitioned thing is because there is nowhere that you can do the synchronization to make that, to guarantee the semantics correctly, because start is local and therefore you can't do the synchronization. You're not allowed to wait for the other start to happen. If there was a blocking start, then you could.
Right.
Non-local start, but whatever.
So I'll make this comment, Martin. Without getting too far into the hardware, there may be ways that you could check locally whether a remote system had a buffer available, or at least as long as you knew that your overflow responded in a certain way and could absorb a certain number of messages, there are ways that technically on some hardware you might be able to guarantee a receive side buffer, or at least know locally whether a receive side buffer was available on that other side. Has the receiver run out of resources or not is the basic question, right? So yes, you may not be able to implement it fully as a no-op. You may be able to implement it as a very lightweight local lookup, though.
Yeah, that's the point. But I'm really trying to shoot for it. Do you introduce a happens before relationship? So if I put a send after the psync and a receive before the psync, is that code to guarantee to deadlock now or not?
No, the return of the psync should have nothing to do with MPI message ordering whatsoever. So your implementation underneath the covers can act independently for psync rather than guaranteeing a send and receive. There's no reason why you couldn't do those things synchronously or simultaneously.
So Ryan, can I use psync to determine that it's safe to use ReadySend?
So this is an awesome question that we discussed.
Right, but it's the litmus test for this, right?
So the answer is that we discussed whether this could be a more general sync question. Can you sync?
Yes, but I think, we kind of narrowed it down just with the P and not just a regular sync because, we were worried that we may be opening a can of worms here.
Hang on. I'm not trying to open that can of worms. Assume that there is a partitioned communication operation that exists and I psync on it. Can I use this fact that I psynced to enable ReadySend on a different operation? So at one send, the receiver posts their receive. We psync on some unrelated partitioned communication. Can the same sender use ReadySend because the psync succeeded?
So is it a barrier or is it a memory fence?
So based on Ryan's answer before, no.
No to which one? There were two questions, Mark.
No, you can't do the ReadySend because there's no what happens before synchronization between the two processes. That's my understanding. That's why I asked the thing about the deadlock. It's the same thing, right?
Yeah, the answer really should be no. Whether or not you could bodge together an implementation that used the same exact buffers and all the rest of it to try to guarantee that it existed, your mileage may vary. The spec should not bless that. That's really hacky.
So I have a conflict coming in just a minute. I'll have to drop. Another question for you, Ryan. I don't feel like you need to switch topics right away, but I just wanted to lob it out into the channel. Can you call MPI psync twice in a row? So the reason why I'm asking is we had this discussion about whether there was any state visible to users from having called psync. So
sure, you can call it multiple times in a row. An optimized implementation will store data letting you know that you don't actually need to handshake in any way, right? But there's nothing stopping you from trying to synchronize over and over and over and over again on the same call as it is currently written.
And so you could call psync, but can you do psync pready psync?
No, because you're prohibited in here to say that the partition communication request must be realized, but must not be inactive, e.g. MPI start must have been called, and no calls to MPI pready must have been made after the call to MPI start. So sync has to happen after start and before pready. You can call it as many times as you want between then.
Yeah,
but once you call pready, you're done. You can't call sync again.
Is it thread safe?
Finished it and called start.
Do the number of psyncs on both sides have to match?
That would be the interpretation I would have out of reading this, because it says that you must call this must be called by both send side and receive side processes for a given partition communication operation.
Yeah, I mean it's non-local. It blocks until the matching call is made on the other end, right?
So you can call it as many times as you want, just as long as both the sender and receiver call it. I don't know what the purpose of doing that would be between a start and a pready. But if you had like tons and tons of threads doing stuff, and for some reason you didn't marshal them and they all called psync, it would work. It's really bad code, but it would technically work.
But let me just go back just one sentence. He said it would block until the other side calls psync, but I thought that's exactly what we excluded before, because then you would have the deadlocks and he would be available to do the ready sends, the ready receives, ready sends.
Mm-hmm.
It doesn't block until the psyncs have called. It just ensures magically that some condition is met, that somewhat a buffer is set up. and the user wouldn't have to worry about it, right? This is not a synchronization in the synchronization sense that we have in the MPI standard, because it doesn't guarantee to introduce what happens before relationship.
In which case, why do you have to call it on the receive side at all?
Good question.
Because you want to be able to poke the MPI library to actually respond to the synchronization. Not all implementations may be able to handle this entirely out of line. That implies that there's strong progress going on. So for weak progress semantics, you really want to call this on both sides. And you could respond to this stuff. Realistically, underneath the covers, what this really is, right, is ready to send, clear to send. But if you have no entry back into the MPI library, how do you guarantee that you could ever get CTS back before you call P ready?
But start is able to do the clear to send. It can fire that at the sender and hope that it arrives, right? The start call is sufficient on to notify the sender that the start has happened, and that's.
I think one of the idea was that you would delay the registration so that you can overlap it. So the start might not have done the registration yet.
Yeah, so if in an implementation where you didn't have strong progress, and therefore, when is this thing going to get registered? I think you would want to implement that so that the latest point you can lazily delay that to is the end of start. Otherwise you're risking having an arbitrary delay until the user does something else in MPI, which might be the wait for that operation, right? You're not overlapping anything. Well, that's fine. That's valid implementation. It's just not going to perform very well. If you want it to perform well, then the start would do the stuff that is necessary and fire the clear to send at the sender. The sender might want to actually block until that thing arrives. Okay, fine. The initial calls aren't blocking, aren't non-local. You need something non-local. You need this psync thing, right? But then it would be waiting for the start to tell it that something's happened. Or if you have an implementation that's really clever and has strong progress, that message might actually be sent by the progress engine sometime after start, right? Or it might be sent during wait from the receiver when you next enter the MPI library, and I don't think that you need the psync on the other side. Or at least it's a different thing on the other side. It's not, and it doesn't necessarily have to be blocking on the receive side. It could be a non-blocking or an immediate call that just fires something at the sender and then carries on.
All the receive side is doing is guaranteeing that the receive side buffer is ready to receive data.
Yeah.
Right? So yes, you're right. It's going to return very quickly on the receive side.
Yeah. So it doesn't have to be non-local. It doesn't have to wait for the psync on the sender side. Whereas this using the word synchronization and saying that the call is non-local, irrespective of which side you're calling it on, suggests that it's non-local on the receive side as well, that's not necessary. Unless you actually do mean that it really does synchronize, and this is actually like a collective over two processes, in which case the blocking synchronous mode send, blocking receive before or after would deadlock in Martin's question. That's the way to test, is this thing actually going to do a happens before relationship? If you replace this with barrier, it would certainly deadlock if you put a blocking synchronous mode send before and a receive afterwards. So is this a barrier or is it a memory fence?
It is a synchronization of the availability of a buffer.
So it's a memory fence.
In that term, it doesn't, but it's not a memory fence in that it doesn't guarantee that operations to the buffer have been completed. Right? It's just the agreement that a buffer is available and
but there are no accesses to the buffer. You're simply okay. Maybe not a read fence or a write fence or what. You're not flushing memory. It's a memory operation, not a lexical. I've reached this point in the program at the other side.
Yes.
Right? It's not a barrier. In which case, I think I would advocate not using the word synchronizes, because one, it's overloaded in MPI already, and if you're not using one of the two existing meanings of it, then please don't introduce a third meaning for that word. Try and find some other way of describing that semantic.
But coming back to in the same vein on Dan's initial question, why do you need it on the receiving side? I don't see this, because psync could block on the sending side. It would have to have it's a non-local function. It's a function that requires progress on the other side. So it would be a local function that requires progress. At some point, you have to call the wait for the P receive. So there is guaranteed to be progress, and we never guarantee anything else in the standard. So why would that not work in this case?
Are you advocating that it's actually local then? That all it requires is progress on the other side?
Yeah.
Or because to be non-local, it has to block execution, waiting for a particular related MPI call, which would be wait potentially on the other side, right? If there was nothing else, it would either be start, or it would be wait. You'd have to designate it's this one or one of these sets.
Yeah, that's kind of what I'm advocating, because if there's no counterpart, it can't be non-local.
It doesn't have to be the same thing. It doesn't have to be psync on the other side. It's still a synchronous mode send is still non-local, even though it matches with a receive, right? So it doesn't have to be the same function on the other side. But as long as you can say it's waiting, it's blocking execution until this happens, one of these things happens.
There's actually another point, right? If it doesn't introduce a happens before relationship, and you don't have all the thing with the send and receive we have, it doesn't wait for the function, right? So it is actually local by default, even if these two things have to be called. That was the test that Rolf introduced in the whole semantic term discussion. It's non-local if it leads to a deadlock if you put a send receive around it.
Or could do with a valid implementation. It's not necessarily you have to implement it that way.
Correct. But it could be with a valid, yes. So in this case, it is actually a local function, even with the current idea of having it on both sides.
Well, when I vote on the semantic terms ticket, Wesley.
Would you like me to announce the results?
We just go back to what we all had before that just made all this simple. So you don't have weird communicating functions that wait for other sides that are local.
So Ryan, you're going to make the change based on the outcome of that vote.
The thing is, we should still have this discussion about semantics, even if we don't, irrespective of the terms and what words we're using to describe these things. We should still have this discussion about the semantics of, will this thing actually block execution until some specific thing happens on the other side? What is that specific thing? If it is waiting for a psync on the other side, then that's a synchronizing call. It's what we mean by synchronizing in the sense of collective synchronizing. If it isn't waiting for a psync, then why do you need the psync on the receive side at all? If it's waiting for anything in the start or wait or whatever set of procedures, it's still waiting for something. Is it waiting for something or is it not waiting for something? If it's waiting for something, then it creates a happens before relationship, and you can deadlock by putting a blocking send receive around it. If it's not waiting for something, then you can't deadlock using that, but then it's not waiting for anything. We need to know what the semantic is, and I don't care what terms we use. I do care a lot, but it doesn't matter what the words are that we use to describe that. There is a fundamental question about what the semantics are. And we would still need to have that discussion, even if we didn't have the terms to describe it.
Yeah.
The discussion that technically I misspoke earlier, Martin. Yes, it may have to wait for a specific call to happen at the other side as it is currently specified. So yes, if you put something blocking in the way of the receive side that will not complete, yes, it could block. You would reach deadlock.
You guaranteed to reach.
Yes.
Deadlock.
Yeah, because the other side will not be able to return your ready to your clear to send. Right, and you're waiting there for clear to send while the other side's waiting for you to send it something. You deadlock.
Okay, but that's only one way, right? The other way around, it wouldn't block. So you have, on the sender side, you have a non-local function. On the receiver side, you have a local function.
Yeah, because we're only guaranteeing something that's happened on the receiver side.
Right.
So and we only care about the receiver side. So that's why there's this, dichotomy between the two, that they're not exactly identical. One side is guaranteeing something to the other side, and the other side really isn't guaranteeing anything. It's just asking about the status. But it's saying, I'm blocked until you let me know that this thing is true.
So we have an asymmetric non-local function.
So there's precedent for that in that you can do a blocking synchronous mode send on one side and a non-blocking receive on the other side that releases it. So I think that's not a problem.
Okay, I definitely want to encourage this discussion further. For the sake of me reading 7 more lines, I'd like to finish reading the ticket just because this blends into this discussion here relates to this next call.
Would you like to finish reading the ticket, or would you like me to announce results? If you only have 7 more lines, maybe you can finish.
I'll just read the ticket if people agree not to interrupt, and then we'll have discussion after.
No, Corey is hanging on pins and nails.
Discussion will be generated.
Wes, if you don't mind, can you re-enable submission? I forgot to submit.
Yeah, okay. So Ryan, you go ahead. I'll let Hari submit, and then we'll finish.
Okay, so the next function is MPI psync all, which takes an array of requests. And this performs all synchronizations associated with requests in the array of requests. A call to MPI psync all has the same effect as calls to MPI psync, executed for 1.0 to count -1 in some arbitrary order. So this is the same basic text as the start all. As MPI psync is non-local and blocking, the order in which the operations is performed in the MPI library will not cause deadlock due to operation ordering. And this is simply because underlying what you're asking for is you're sending a ready to send and you're waiting for clear to sends back. So the actual order that they're ordered in from the other operations should be able to be handled inside the MPI library without causing any blocking. But this is just because psync blocks and you may have some ordering issues, this helps solve your problem that you can just call it for all.
Can I make a pedantic point, which is, very different than all the rest of the conversation that has happened so far? It's equivalent to executing 0 to count -1 in some arbitrary order. That is a C outlook on the world, not a Fortran outlook on the world. Do we care?
I'm happy if Fortran people want to help me craft some text to give them warm fuzzies, Jeff, and include that. The only reason that exists there is
for like start all and wait all.
Yeah, this
I remember changing this. I remember changing this in response to a Bill Gropp editorial thing. So there may be a precedent for how to write this differently already. I'll dig that out in a minute.
Thank you.
If there's an updated version, I'm happy to update it. But like I said, this is just how start all works today. So.
Yep.
So Ryan, I have one more fundamental question just to understand your ticket. So the psync is, the idea is you add the psync after you start the send receive, so that the p-ready call can literally be just setting a flag and you have no other control path in there. That's correct, right?
Yeah, so this is probably the easiest way to think about it. If you think about the GPU case, at least.
Right.
You're putting a call in between here, MPI start and kernel. You're doing a psync so that when you do the p-ready over here on the kernel, this is super, super easy and fast.
So Right. So that's how I understood it, and that makes sense. But the sync is an optional call, right? So a correct program doesn't have to call the sync.
You can choose not to call the sync, which is why we're working on info keys here, so that we can attach an info key that tells you that I guarantee you I will always sync buffers. That will make things easier over on the GPU side. But you're right. You can write a program without sync, and that is correct.
And so the P-ready has to have an if in there no matter what. Have you been synced or not?
Yeah.
So
yep, the P-ready has to do one if.
So wouldn't it be better to also for semantics to have a MPI's P-ready synced? There's only allowed to be called after they have a sync call, and then the P-ready, or have another condition to it?
Possibly. I don't know what the performance ramifications of just that single if call are. We'll be able to tell you in a little while.
I mean, if that if call is accessing some shared data structure amongst all the threads, then I would assume it would be costly.
Yeah, although it would be a shared read. There would be no write happening.
Yeah.
It would be read-only memory, right? You'd be guaranteed that none of the threads ever modified it on the kernel device itself. It would be written from the CPU as a flag.
But at the GPU point of view, right, an FPGA, this may look, if I have to write VHDL around this to check something in the main library, whether that flag has been set before I can actually issue that other flag, that is, for example, that could be quite costly or quite complex at least. I think it would be helpful to have a P-ready that's guaranteed to only that where the guarantees are set up.
I agree.
Okay, well, I mean, it's trivial to change the to add a P-ready that matches up with sync. So if the forum as a whole would like that, I'm happy to bring that back next time.
I mean, that kind of further reinforces, I think, Martin's point that the psync is only really useful on the send side, though. That I think the receive side part might be okay to get rid of.
That's the one thing. And the other thing, you may not even have to talk about synchronizing the buffers. You can do a P-ready synced if you had called a sync before, and an optimized implementation can then use this to actually sync the buffers. But you don't even, the user doesn't even have to be aware of that synchronization, right? You can say this as an advice to implementers or as a rationale, but you don't have to get around what we just talked about, setting up the whole terminology about this halfway synchronizing thing.
Wait a second. So you're saying call MPI P-ready sync and don't have a corresponding sync call with it?
No, you have a second call called MPI P-ready synced. You're only allowed to call this call if you called the sync call on the send side beforehand at some point after the start, before the first P-ready synced. That's the only definition you have in the MPI standard. And MPI implementation can then use this to synchronize if it wanted to and be optimized for a GPU. But you don't have to basically specify the synchronization, blocking, non-blocking, local discussion, all that we had now, because the only requirement on the API is you call start, you call sync, you call P-ready sync.
Okay, good point. We did have this discussion about a synchronization call in the working group that really only needed to be called from one side, and why that's a little odd. If the forum wants that, that's perfectly fine too. I mean, we chose what we thought would be most palatable to folks on the forum, instead of well, how do you have a one-sided synchronization call and why does that work? But if that's the feedback that we're getting, certainly you're right. You technically only need it on the one side. We're gonna have to come up with some sort of extra terminology here too to describe this type of behavior.
Well, the one side is just a nice side effect, but I think what Dan also pointed out about the terminology of synchronizing is gonna get really ugly, and this would just sidestep the whole thing and get you what you want.
Sure. I mean, I'm all for changing terminology to make things faster and more acceptable by the forum. I'm a little bit of cautious as to designing the API to avoid semantic terms. So, yes, I agree. It makes it easier for my ticket. I'm not hugely a fan of the precedent it sets of trying to design the API to avoid using certain terms that are loaded, though. So, just as a note, I'm happy to change it for this ticket. We should be aware of the ramifications of that going forward, that I wouldn't want that necessarily applied to all of the tickets. But
I think it's a good precedent from the point of view of, if you're going to use the same semantic, then use the same word. If you're going to invent a new semantic, then use a different word. I think that's exactly the right way forward. Don't overload a term and provide a complete or a subtly different meaning. That is the way that we have gone in the past, hence synchronous mode and synchronizing. They aren't the same thing, and we shouldn't try and conflate them. So let's not do that again.
Can I push back a little bit on the idea that sync should only be one-sided? I might not be right, and I might still very well be confused over this, but it just feels weird to only have to call sync on one side, because that implies that you've got a passive target, and that has implications.
There's no synchronous receive. There's
hold on.
Okay.
So if we do want to split it into two things, though, I mean, there's tons of precedents for having sync on one side and ACK on the other side, like a different name, because I'm doing something different. But those together comprise like a sub operation or something like that. And I'm sorry, Ken, I spoke over you there.
No, I was butting in, but I was just someone just raised the point of synchronous send. Synchronous send is something that the sender gets to know some extra information, right? It's kind of one-sided because the receiver doesn't necessarily know that the send is synchronous. I mean, the implementation does, but the application programmer doesn't know that necessarily.
Yeah, and the application never necessarily gets to know that the send was synchronous or synchronous mode. Right. But also MPI doesn't know when you initiate the receive whether it's going to be matched by a synchronous mode send or some other type of send. So actually, even the MPI library doesn't know until it arrives.
Sure. In this case, having the receive side sync makes life a little bit easier from an implementation point of view, I believe, just because it's a good hook for you to handle a certain case. Shoving it into other parts of the implementation, sure, you can do it. Just as a note, that's why we chose this design in the first place, was just simply because it greatly simplifies how you'd want to implement this stuff, while giving you lots of options, because you're getting a ping from the receive side. So that was the reason behind some of why this was proposed. I agree, technically you don't technically need it, but it certainly makes implementers' lives easier.
So I think the strongest argument
gives you the possibility, if you wanted to, you could do an active receive, right? Or an active sync from the receive side, right? Even if you haven't gotten anything from the send side yet, you could send something over to the send side saying, hey, I'm ready.
Yeah, I agree, Jeff. I think the argument was that you could potentially also do that from the start. The API start could proactively send the clear to send, and you'd be okay there too. It's just this having the sync on both sides is easy for the implementer to have that hook to know to do that, right?
Right. For reasons you cited earlier, right? You might want to do a lazy registration too, right? You might not want to do the registration until, nope, never mind, forget it. That was a silly argument.
Yeah, I think to me the strongest argument against a one-sided, although that's a bad word to use, synchronization, which is a bad word to use, would be if if it requires an active message, because active messages generally, if as soon as we say that requires an active message, it kills it, right? So does this require an active message on the receive side? If it does, then you need a two-sided protocol to avoid that.
An RPC style action. How about
Yes,
that?
that semantic. Yeah. What happens on the receive side? What is the sender activating or causing to happen on the other side? If it's just reading a flag, then most RDMA networks can do that. What about things that can't do RDMA?
So my comment would be, maybe you could do this. I will point out that an optimization you can do between the start and the sync calls would be that if you were trying to say pin memory, you could do that in the start call. And then when you have a sync call later, actually send the clear to send, assuming that you do anything in between those 2 points, right? You may not actually need to do that. As to whether the call needs to be active or not, it depends on what you were able to do in the start. You just have to be able to make sure that you are able to write to the buffer. So I think there are implementation ways around it. Could I come up with an implementation that can't wait for memory registrations or do registrations and start that could require an active message? Maybe, but I can't think of any reasonable implementation today that would do that.
Could I implement it by just sitting, waiting, looking at the network card, waiting for a clear to send message to come in from a sender, from the receiver, and when it arrives, I come out of the call. I don't actually send anything to the receiver. I never do. I don't go checking. I don't attempt to send anything down the wire. I'm just listening, waiting for the receiver to do something. The receiver will send the clear to send message to me in the start. Correct implementation, we're done. No active messages needed. Is that valid?
Yes, that's valid if you're guaranteed to send the clear to send in the start. That's an implementation detail.
Right, so ignore my objection then.
Okay.
So just as an aside, I put in the chat window a reference to pull request 225, which has been accepted, which is labeled as replace the CBIOS pseudocode. It takes the things for wait all and so on that do, the same as calling this with an array and, with pseudocode that looks a bit like C but isn't really, and it replaces it with words. Follow that and the objection to the C code will go away.
Okay, we'll update that for next time. All right.
I mean, the one-sided, two-sided aside, I think that's almost independent, but I think it would be nice to find a way that we could have a P-ready and probably in contrast a P-arrived call as well that really could be implemented without an if separately on an accelerator. Because I think that's the original intention of the idea. Independent on how you do the sync beforehand or what you need, or if you put it in an info key or in the start or whatever you want to do. But I think having a P-ready that could be guaranteed to be implemented like this would be useful, where I don't have to do an if and say, oh, am I synchronized or not?
Well, that's true. If you put in an explicit call, you will guarantee that you don't always have to do that. The goal here also was, though, that we thought that you could put an info key on the communicator that would alter what MPI P-ready implementation you loaded onto the GPU with your kernel. So you'd actually know by the point at which you were loading your kernel which P-ready you need to actually implement on there.
So an info key assertion attached either to the communicator or to the partitioned initialization call, assuming you had the info key that you've missed. If you had an info assertion where the user said, I will always call psync for this thing, then you would have the guarantee at the initialization time. You could then use that. MPI could rely on it because it's an assertion, and you would know that the user is guaranteeing there will be a psync call, even though the standard doesn't say it's essential, it's optional. The user could choose to not do. They are asserting they will, and therefore you could rely on it and remove the if.
Well, yeah, but that's dynamic. And so if I have an FPGA with a pre-prepared bit stream, which P-ready is in the bit stream?
So you would have to have two kernels, or you'd have to push the thing onto the GPU would be different, right? You'd push on a kernel that had the P-ready with no if in it because you've got the info key, or you'd you'd send a P-ready with an if in it if you didn't have the info key.
But on an FPGA, that's much more than a kernel. It's my complete design of the chip. That's a huge overhead.
Yeah, but that's the way that we've got this. Unless you start making the psync call mandatory, which is fine. Yeah, you could do that. But then I would probably want to maintain the generality. And if we're really going to accept the way this current one is, I'd probably want some other name of initial. This is a different operation. One where the psync is necessary, and the other one where it's not allowed.
Yes, that's exactly what I'm advocating for. It would be nice to have a second P-ready call that exactly does that, instead of modifying the behavior of the existing one. The existing one has to do all the ifs and all the fancy stuff, and if you really have a other one, like a synchronized, then there has to be some action beforehand, whether that's one-sided or two-sided, which guarantees that I can put this in a design that allows me to just trigger something without any questions asked.
So a P-really ready.
Be ready for sure. So that's okay. So that was the one comment. The other comment I had, now whenever we're talking about progress and the idea of advancing one-sided active messages and stuff like this, a little bit of an aside, if we do all this, and the idea is really to put the P-ready and the P-arrived into the GPUs, into FPGAs, into any kind of future fancy accelerator, do those still participate in progress? Or are we guaranteeing they participate in progress? And if not, does this change anything for us? Because now we suddenly have an MPI call where you're quote unquote in the MPI library, but you're not making you're not helping other make weak progress. This will be the first time we do that.
I think that's not true. I think they're only very, Pavan pointed out that there are only some calls that guarantee they will make progress. Things like can comrank, well, is comrank forced to do progress? You can implement progress in it, but should you? Are you forced to? What about all the stuff to do with an info key set or something? You know, the completely local, nothing to do with an operation ones. I think that's at least ambiguous as to whether they are forced to do progress. I think the answer is no, they aren't.
So if I do on the receiving side, on a GPU, FPGA, whatever it is, a P arrived in a loop over it and do nothing else, is that a legal code then?
So nothing would do progress unless the CPU is also doing a wait or something else that does do progress, that guarantees progress. Or at least that was the discussion we had in the partition working group was that you absolutely don't want to try and push progress, a requirement to do progress onto the GPU or an FPGA.
No, that part I completely agree with. And that's what I'm trying to avoid. That's why I'm asking.
So something else must do progress. And also, if you're just looping on P arrived, what you really need is progress remotely at the send side. So that's not quite the same thing. I think to me the thing is if the CPU is doing a wait, I asked the question of could you concurrently do the wait on a CPU at the same time that the GPU is doing P-readies. So I do start, asynchronously launch the kernel, and then on the CPU, before the kernel is finished, call wait, which would block, right? And it can't return until the operation is complete. The operation can't be complete until it's properly started. It isn't properly started until all the P-readies are done. So I can tell when all the P-readies are done on the GPU by calling wait on the CPU concurrently with those calls being done on the GPU. So the GPU would have to then keep telling the CPU, I've done another one, I've done another one, I've done another one. CPU would keep a count of how many, get to the right number and say, yeah, great, no problem. The kernel is still running on the GPU, right? And Jim responded with that he thought that the whole execution model was like displayed here, that you would do start on the CPU, you'd launch the kernel, you'd wait for the kernel on the CPU, and then you would call MPI wait to complete the operation. So the user is guaranteeing a synchronization between, as in all the p-readies must have been called before the user will even attempt to call wait. You can then take the GPU out of that question, and what are these are threads? Is it possible to, is it allowed to call wait before all the p-readies have been called? Can I do them concurrently? Could I have one thread call wait and expect that it will block until all the p-readies are called by the other threads? Is that useful? I don't know. Is it allowed? I don't think it's necessarily excluded by the text I've seen. So, you know.
So the one thing that worries me a little bit is with this discussion, we would be making an explicit architecture limitation of saying that you have to run on a host and an accelerator at the same time. You have an architecture that can only power one of the two at one time. This would not be we wouldn't be able to implement an MPI implementation on top of that anymore. There's no guarantee the accelerator and the host will run at the same time. And we've seen architectures like that, at least proposed.
Well, be careful there. So I think you can make a valid MPI implementation out of that. It's just that the progress only happens when the host is the active mechanism, right? So all you're really doing at this point, it's not like you're creating a whole bunch of MPI on your accelerator, right? You're literally just marking stuff that has been queued up for you as ready, and then you're returning, and then you're making progress, right? We've never had this.
That's fine. I'm not worried about the ready. I'm worried about the arrival. And if I have a loop on the accelerator around P arrived, and if P arrived doesn't make progress, I suddenly have a dead process.
Yes, in that context, if you can't run a progress engine, you probably shouldn't use P arrived. But keep in mind that P arrived for massively multi-threaded systems, right? It's assumed with the partitioning that you had the capability to run a progress engine. This stuff in these proposals now are cases where we are environments in which running a progress engine is probably not a really great idea. So you're right.
But
there's these concepts and spaces where we need to run stuff that we didn't have these restrictions ever before.
I think that's a spurious argument, because if I had a weak progress MPI and I looped on something that didn't do progress, for example, incrementing a number, right? Just some random thing for a long time, I wouldn't expect progress to be done because I've got a weak progress model.
Correct.
Right? So that's not going to affect anything, because if my program is correct, eventually I'll come out of that loop and I'll do something that does do progress, and MPI will resume. It just takes a long time. It doesn't perform well, but it's correct. I think that's valid even now. Take the GPU out of the question, take everything else out of the question. I can still arbitrarily delay a weak progress application by just looping on some random thing. So
well, it's not random. I'm making an MPI call in there, and a user would assume that as soon as I keep the MPI library happy, something happens. But in this case, you couldn't even respond anymore with the right buffer location for the synchronization, because you're stuck.
Loop on MPI com rank. Just tight loop on that. Would you expect progress to happen?
Actually, yes. We can discuss this, I understand, but as a user, I would say I'm calling MPI. Why is it not happening? As an now when we talk about the details, sure, and we have our discussion here, but a user would expect it, I think.
So I think if the answer to the com rank question is yes, because every call to MPI is required to make as much progress as it can, then I think that a P arrived, it's an MPI call, it has to make progress, because there's a general rule that it applies unless you explicitly exclude it from that requirement. And then you have to put a great big warning with flashing neon lights around it saying, this one doesn't do progress, be really careful.
That was the initial intent of my question. Do we have to do this? Are we in a situation where we have to consider this? And it was an open question. I'm not 100% sure. I'm just worried about environments that where you, for the short time where you are an accelerator, can't make progress. We don't have to finish the discussion. It was just a question I wanted to throw up that I think we have to consider.
Yeah, I'd say, Martin, at least we really need to consider how we can. I would say we need functions that are exempt from this requirement to at least make modern accelerators work. So we need to figure out how to get that in spec.
Yeah, I think that's a good way to summarize it.
And of course, this ticket is difficult to discuss. Luckily, we're always in the same time slot. This ticket is discussed in the hybrid accelerator working group and also the partition communication / persistent communication working group. So it is a constant topic that we typically discuss every single week on Wednesdays. So if people want to get involved in this and have these larger discussions, please try to join those working group calls, join the mailing list so you get the notifications of them. Because there's a lot of moving parts here. But you know, it would be nice to have an answer for accelerators and GPUs, at least something that we can use on them, even if there are some caveats in that 4.1 timeframe, so we can discuss this in 4.0. I think there's some stuff we got to work through, but remember, this ticket is a 4.1 ticket. So we have plenty of time to discuss this stuff. The working group's going to continually make progress on this, and you're going to see this a lot over the next little while.
No, man, I think it's a fantastic start for this, and the discussion I think was good and shows that there's interest, right? I think that's for one that's a great thing to do.
Yeah, I should mention that we do have participants in the working group from the GPU accelerator companies, and we're trying to draw some people in from places like Xilinx to have these discussions too, just so that we make sure we cover all of the technical details and make sure this is right. So this is not just coming from MPI Forum folks, it's coming also from the vendors and makers of these accelerators and what they need and what they can provide. So we're not taking a shot in the dark here. We really are trying to work with everybody to come up with a solution that works for MPI semantics, but also is really efficient for accelerators. Okay. Any other feedback or questions, please, post stuff on the ticket. We can have more discussion on what we're thinking and why we're choosing the stuff that we're presenting to you guys at this point. If you want to look at alternatives and other stuff we considered and sort of why we settled at this particular type of semantic at this point, you can take a look back at the virtual meeting that we had 2 weeks ago. I discussed some of the other alternatives that existed as well during there. So just look at the announcement for this ticket and gives you the link to the YouTube video and the timestamps to start the discussion. Okay, great. So officially we read all of that. It's all going to change, but officially I guess it was a reading. So
yeah, we'll just
know
the
alternative for you. You got 45 minutes for results and your ticket. So hopefully we can keep the time.
Sure. Thanks.
Thanks.
All right. Let me share. The buttons are moving around. Okay. Here's the results. Sorry to keep people in suspense, but given that the voting was complicated this time, I did not want to get it wrong on the Google cache. So all the no-nos passed, so that dramatically simplified the rest of the votes. The ticket 120 did not meet individual ballot quorum, so that one did not pass, and the rest of them did pass. So if anybody is confused or thinks I might have miscounted, by all means, let me know. Be posting the full ballots as per usual online, and if you'd like to see them now, I can show them to you now. I just didn't want to post them up until we knew that they were correct. So any questions on these? By the way, the results I'm showing down there at the bottom, since the only vote that that didn't pass is 120. That is the voting ballot for ticket 120. Yellow means abstain and red means no. Green obviously means yes.
Okay, any comments or questions on this one?
Is Rolf actually on the line?
He was before?
Yes. I'm negatively surprised.
In this case, do you want to ask questions? Do you want to have a quick discussion on the vote, Rolf, or do you want to do this offline?
Yes, it would to have some answers from the many abstains.
So Wesley, that probably would mean that you have to move your ticket. Is that okay with you?
Yeah, like I said, mine's not in a hurry.
Okay. So anybody want to go first? So then, since nobody wants to start, let me start, Rolf. My abstain had two reasons. For one, we had this discussion last time if it's really a necessary addition, in particular since it doesn't cover all the communication cases, and it only has this one parameter, as we discussed before. That made me want to think about it, but that was kind of what made me ambivalent about this. The other thing was the question I sent you today, this morning. I actually don't think I wanted to think through the use case. So I think it actually doesn't do what you want to do. And that's why I wanted to, at least until the second one, to think about it. That was my reason for the abstain. Anybody else of the abstain want to say something? I think Tony from UTC, Tony's not here anymore, right?
Yes, Tony already announced that he is against. That's UTC. Huh?
Yes.
No.
My reasons were similar to Martin's. I did not have the time to think all these through. I probably won't. It is also somewhat influenced by prior stuff in this area where it helps 3 people in the world. And we add a major section, which then adds a lot of burden for minimal win, which could have been done as a library. And I'm not saying that's absolute. I'm not making any judgments here. I didn't vote against. I abstained because I'm sorry, I did not have the ability to think through all of this. And so, yeah.
I think that's similar from my end, particularly the part about, and I think this was a point that Tony had raised previously, that it isn't clear that this couldn't be done with a library in a way that wouldn't have a lot of performance difference between doing it outside or inside the spec.
That's kind of the Argonne position as well. It's you know, if this would be an implementation burden, if there's overwhelming support for it, then you know that's something we'll take into consideration when putting it into MPitch. But yeah, maybe if the library solution is possible, and I think we've had discussion about why that would be difficult. I think specifically because MPI has information internally that you know isn't necessarily exposed to a library if it were to want to implement this. But maybe a shorter path would be, can we expose that information through MPI or PMI or something like that that would enable this type of thing to be done outside of MPI. I think we would support that more so than this.
Anybody else want to say something to this?
Just from the Sandia side, I mean, same thing about implementation burden. and this could potentially be done in the library. But also from our side, at least, the abstain is also that just from our application side, I don't have any users that have said they want this yet. We're still looking. So we didn't want to vote no because we didn't think it was not useful to us yet. We just haven't found a good application driver for it yet from our side. And there are a lot of applications, so I don't want to say from our side that it's not useful yet. But you know, we're still looking. But as of now, we haven't found anything that needs it.
Does it mean that if you find something that you may come back and say, in 4.1, I want to see it?
If I find an application locally that tells me that this would be a very useful function for them and they will see application improvement, I will happily come back and try to champion this coming back. But until we find that, unfortunately, we're in abstain. But yes, not only would you get our yes vote, but you would get active support. But like I said, I don't have that application driver at the lab yet.
Any more comments, or Rolf, any comment from you?
Yeah, I just want to second what Ryan says there. You know, I think this is kind of always true from the implementation perspective, that if a user or customer or whatever you know, comes in and says this is something we really like, we think it would be beneficial, that's always a helpful thing. You know, obviously we don't, that's not always something that we have for every proposal in MPI. I think in this case it made more sense because the use case wasn't clear outside of that.
Mm-hmm. Okay. Let's go on the English. Do we have another answer from Lawrence Livermore or from NEC?
I didn't see that your initial goal will be successful, that you get an optimized version for this function. And it's important for the implementation to have such functions within which are not really useful for general users.
You think there is no optimized software available for that?
I think that if you see your rationale, which had many problems, where you requested an optimized version of this function, an optimized version, you see that all the implementers have a problem to provide such an optimized version in order to have a high quality implementation.
We have produced this 2 years ago.
Yes.
For Euro MPI 2018 and published it 2019. Both at Euro MPI. That's a surprise for me. But thank you.
Okay. Rolf, do you have the answers that you needed to decide on how to move forward on this?
Was there somebody from Lawrence Livermore giving an answer?
Catherine's still there? I think Catherine had to drop off for another meeting.
Catherine's dropped.
Yeah. You would have to send Catherine. I think Catherine was on before for the voting part, so you may want to send an email. I'm not sure if Tennessee Tech is still online. I don't see them either right now.
One answer is what is TN Tech?
Tennessee Tech.
Tennessee. Who is that?
I don't have anything additional to add.
Oh, Thomas, you're still there. Okay, thanks.
Okay, then thank you for the answers.
All right. Thanks, everybody.
One small question to you, Wesley. What should have been the what would have been the quorum?
So it needed 23 votes to pass. So this was this had 22 yes plus no votes and 8 abstain. So it needed one more of those abstains to switch.
Okay. And there's no who wants to switch.
Well, we've already passed the ballot for this time, but you can of course bring it back up at the next meeting.
Well, it's failed ballot quorum, right? So it doesn't mean it's voted down. You can bring it back unchanged next time if you want to.
Right.
But it would probably be good to have a discussion on some of the concerns first.
Okay.
It hasn't failed, right? So it's not something that's taken out of the process. It's still sitting at the first vote state technically with the no attached.
And the no, it was true. Yeah.
Yes, the no did pass. So anything that changed is now part of that ticket.
Okay. Thank you very much. I don't want to spend more time on that.
All right.
For now.
Thanks, Rob.
So then, Martin, I think it's back to you. And we'll delay it to next meeting.
So I have about 10 minutes that I wanted to talk about, but probably even less than that. Why don't we do that first, and I can give you the rest of the time, Wesley, if you want. Unless you want to just push it to next time.
Sure, 10 minutes. Right.
Nobody say anything against what I'm saying, and
Yeah, I think I'll just delay. I don't know how much time there will be left, and like I said, there's no rush.
So this could go very quick, right? So the first one is virtual meetings. We have our next voting meeting, September 28 to 30. That replaces the Austin meeting. We have, if I did my calculations right, exactly 3 slots for virtual Wednesday meetings that fall outside of the 2 weeks, if you wanted to do something that's relevant for the meeting. So then you have September 16 and 23, which are within those 2 weeks, and 23 is already overlap with Euro MPI. I won't, Wesley, correct me if I'm wrong there. That's correct, right?
Yes.
So I did some notes during these last 3 days. The topics that I thought people suggested, or that I suggested for these virtual meetings were, for one, we had some comments on 137, the big count, which we deferred until next time for the vote. So that would probably be good to talk through. There's the external document for the table, 96. I would imagine that's probably good to run through too before we get this into the voting process in the next meeting. And then the MPI type shared discussion, the ticket 301 that you pulled after discussion yesterday probably should be discussed as well. And in addition to that, we I already said we had some requests from the OpenMP community to have a discussion with them on things like progress, shared task management, how to interface. Do we need to interface the 2 standards, or is it a bad idea? That, of course, doesn't reflect any current ticket, but there will be a discussion with them. So I think we should prioritize definitely what we need for 4.0. So I think we probably should schedule these 3. Yeah?
Martin, sorry that I didn't get that ready for this meeting, but somewhere in those, I would potentially like to discuss the pending errata item that fixes the info handling outside in it finalized now that that session is in.
Mhm.
It kind of dropped my agenda, but I would really like to see that in 4.0. So we have consistent handling between 4.0 and 4.1 or something, and tools won't have to always check like what kind of implementation we have here.
Good point. Yeah. Do you
Should,
have
should
a?
be small, and I would also be fine if most of the discussion goes on the ticket. There is no ticket really yet. So I don't want to take real discussion time of the virtual meetings. Just want to make sure September is the last day to really get this up and running. So I want to get all the quirks out before September.
So that sounds to me though that this is typically a very hairy discussion around in and finalized that probably benefits from a virtual meeting.
Okay.
So this means we have 4 top. So then
I
let
don't
me
know what
ask.
you're talking about, Martin. And it and finalize, it's really simple stuff.
Yeah, use.
It's all been superseded anyway, so I don't think there's any problem with it.
I think you also mean.
Yeah, but Jeff, you know me. You know, I just propose a sentence and then you know, we block all the meetings.
We jump all over you. That is the way. Yes.
All right. So, Dan, do you have a feeling how long you guys would need for the big count update? Is it a full meeting or is a half meeting would be good for that?
Probably about a month and a half. Yeah, something like that.
No, seriously. So do you, probably just to be sure, we probably need a full one for that. Do you have a preference?
So I'm not going to be at the September the 9th meeting, you know, come what may. So I think it's got to be one of the other two. I suspect that we should probably timetable both. The external document one should be a fairly easy thing to do, and then we can discuss, you know, and it might be a very quick discussion if we just saying, you know, the appendix is now in a document. Everybody okay with that? Yeah, sure. So that might be a really quick thing. The big count thing, there are some outstanding things. There's a comment by Josef, which I think that requires a small change that we'll need to discuss. There are some comments by Rolf that need discussing. They might result in changes. I'm not sure yet because I haven't had a chance to give it brain space. So I think we should schedule it for the 26th. Both of those two things together. It will probably start. My feeling is that we would be able to knock off the 96 thing fairly quickly, and then use the rest of that time for 137. That might see it done, but that requires us to get on and do certainly the big count stuff. Actually resolve those things soon enough that we can get that ready for that time. If not, then we might steal some of the September the 2nd meeting to carry that on.
Okay.
If that's okay.
I think Guillaume, are you still there?
Yeah.
Would the September 2nd, also with the caveat of Dan potentially sharing some time, would that be okay with you?
Yeah, definitely. I'm not available on the 26th, and I won't have anything ready for that this time, but anytime in September is fine with me.
Okay. And then Marc-Andre, September 9 work for you? You see the most time to actually prepare the ticket?
Yeah, yeah. So it's the most time to prepare. But I'll try to set up the ticket way before that, and would be good if I could get comments on that before September 9th. So the virtual meeting has most of the quirks already out.
Okay, and we can remind people on the 26th and 2nd to do that once you have the ticket sent out.
Yeah.
And also, if there is time spare in either of those two meetings, then it could, if you're ready with it, then it could just be shoehorned in at the end of one of those, I guess.
Yeah.
Yeah, sure.
Let's keep this as a rough template and see if we need to shuffle things around. I would then actually just suggest to not do the OpenP discussion. We will also skip the 16th, the 23rd, we have our meeting. We could see if we want to invite the OpenP folks to the face-to-face to get the most exposure. That may be actually the better thing to do. Does it sound reasonable? Because I don't think we have a very full agenda next time, since the big things really have been done this time and the new things are ramping up.
That makes sense. I mean, we'll see what the agenda ends up looking like, but
We didn't apparently have a big agenda this time. We've only got 22 minutes left.
right.
Yeah,
And we've already pushed some things out.
Yeah.
we had ticket 96.
We will have it again. We'll have the table and we'll have big count next time.
All right, so I guess we should ask him for after in the next forum, and I'll talk to them and see what time they would have available. Let's do it this way then.
Could it be done during IWOMP when they're actually active anyway? What about the 23rd?
That's also during Euro MPI.
Yeah, but isn't that possibly a good time to schedule something that both communities are active doing one of their conferences, and so are expecting to be online and so on, and we could have a joint community meeting somehow into those schedules.
That's been a live panel session organized by the chairs of our Euro MPI and IWOMP.
Mm-hmm. Yeah, with the entire community of both things, watching on and throwing rotten tomatoes. Be great.
How we love to work.
Sounds like pay-per-view.
Yeah.
Yeah, you got to register for Euro MPI. That's your pay-per-view. Wesley, do you want to suggest this to Bronis and Michael? Or do you? I don't know what are we planning with. I'm saying this very carefully.
Yeah, from Euro MPI's side, there's not a lot of time left. But if this is something people want to do, we could potentially push things out and go later in the afternoon or evening European time.
Right.
And it could be tacked on the.
Why don't we take this offline and see what's possible? We did register the wish, and so we'll see what can be done, and if not, we'll do it afterwards. How does that sound? I think we're going to solve this here.
Sure.
Okay. So this is the virtual meetings. So we only have 3, so please make sure to attend them, because the better we get this done beforehand, the smoother with the next meeting will be. We'll set up a similar schedule as this time with the voting block on each day, and only plenaries. Working groups don't make much sense because they're meeting virtually anyway, so please be active at the working groups. We won't have working group meetings at the face-to-faces for a while. That's just what it is. And so it would be good if everybody could just push on their own working independently and just report back in the beginning of the larger meetings. I think that's the best we can do for now. The other thing is this is the text from last time about the voting meetings that we want to schedule for 2021. We actually have the one for December scheduled. I don't have the dates on here. I assume that everybody is still under the impression that spring and summer meetings most likely will be hybrid, if not fully virtual. And does this change for anybody? The expectation?
That's going to be true for me.
Okay, so we'll plan them for virtual. If things go better, we'll think about a way to make them hybrid and see if we have someone who wants to host them. At least some of us can meet. But I think we should be just working under the assumption of virtual for now. It's the same schedule that we have right now. We assume that in September something will happen, but Euro MPI we'll worry about that later. And also we leave the December open because of that. We decided that last time. Anybody have any objections to this time? And that we do a discussion in December whether we want to meet in person. So the other thing I wanted to put up, we put these dates up last time. So we decided on February 22 to 25 because that doesn't conflict with SIAM because it's the week afterwards. We had the May 24 to 27, which had a conflict for a lot of people, which I didn't remember what it was, but there was a conflict. And we settled on June 7 through 10, which actually probably in this case just means actually 24 and 7 to 9, since you only do 3 days. There were some concerns about these dates, particularly within the DOE. that had meetings there. There was a particular one person, I don't want to call the person by name, but there was one person who said, well, if it works for everybody else, that's fine. But we was wondering if anybody else has any conflicts. It's a larger group with these dates, because we don't have much wiggle room to find other weeks because of other problems and conflicts that are in these time frames. So if there are no big objections to the dates, I would just say we'll fix them, the lack of better options, and we'll just go with them. Anybody have any issues with these 2 weeks?
Martin, do we have firm dates for EuroMPI next year and therefore the September meeting, or?
No, I don't. I wonder if perhaps on the OpenMP wiki there's something. Let me check.
Okay. Well, if the answer is no, then that's fine. I was
don't
just going to start posting these.
I don't have it on the top of my head. I can look it up and send you email afterwards.
Okay.
Do you have an alternative for May?
I think June is the alternative for May.
Oh,
That'll be the summer meeting.
okay, good. I understand. Yeah.
No, now that's a bit more clear. All right. Well, so if somebody finds something, please send us email. Let's just do a deadline where I would suggest Friday. If you have any bigger problems with these dates, please send them by Friday. Otherwise, we're going to lock those days in because we need to get them on the calendar. And if only a few people say they can, then we probably have to go with these dates. If there's a larger group saying we can't make it, then we'll figure out another way to come to a solution. Okay, that's basically all I had for the organizational part. That took almost 10 minutes. Perhaps it was 15 in this case. Any comments, questions on this? All right, then Wesley, do you want to do 15 minutes or not?
I'm not sure I can do it in 15 minutes anyway.
Okay.
It's not that long, but what's the point in trying?
That's the spirit. Excellent.
Or
Okay,
in the
that's
words of
fine.
Jim, it's fine.
I think we're all pretty tired after 3 days of this anyway. All right, any last business, any last comments that folks want to make before we close this meeting? Going once, going twice, going 3 times. All right, if not, thank you very much, everybody, for this, again, a marathon meeting. I know it's always a lot of time, a lot of strain on everybody, but I think it was, again, very productive. We came to some really good conclusions. So thanks very much. See you in next week at the virtual meeting and in a couple of weeks at the September face-to-face. Thanks, Wesley, also for, again, keeping us on track and all the other good things. And with that, thanks, everybody. See you soon again. Bye.
Thanks.
Thanks, everybody. Bye.
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 Thank you.